Right now, as you breathe in and breathe out, every second breath you take comes from the ocean, not from forests, not from trees, but from tiny, drifting life, floating quietly on the surface of the sea. As you rest here, the ocean is breathing with you. Welcome to this peaceful journey through the ocean. Let yourself settle in, get comfortable, and simply listen. There's nothing you need to do except breathe and relax. As we explore the gentle wonders of our world's waters, let's begin with something truly remarkable. Oceans cover about 71% of Earth's surface. Just imagine that for a moment. If you could look down at our planet from space, you would see a blue marble with water dominating the view. Nearly 3/4 of everything you see would be ocean. All the continents, all the land we walk on, all the forests and deserts and mountains. They make up less than 30% of Earth's surface. We live in a water world. The vast blue expanses stretch across our globe, connecting distant shores, holding mysteries in their depths, and creating the beautiful blue planet we call home. And here's something even more astonishing. About 97% of Earth's water is in the ocean. Almost all of it. When you think about water on Earth, you might picture lakes and rivers, rain and snow, the morning dew on grass. But all of that fresh water, all the water we drink and use, represents only a tiny fraction of the water on our planet. The ocean holds nearly everything. It's the great reservoir of our world, an immense body of salt water that has existed for billions of years, slowly cycling, constantly moving, forever present, now. You might think of the oceans as separate entities. The Pacific, the Atlantic, the Indian, the Arctic, the Southern. We give them different names. We draw them on different parts of the map. But here's a beautiful truth. There is technically one global ocean divided into 5 regions. All of these waters connect. A drop of water in the Atlantic can eventually make its way to the Pacific. The ocean is one continuous body, flowing around our planet, touching every shore, united beneath the surface. The divisions we create are human constructs, helpful for navigation and study, but the water itself knows no boundaries. It's all one endless sea, and what a sea it is. The Pacific Ocean is the largest ocean on Earth. It's so vast that it's almost difficult to comprehend. The Pacific covers more than 60 million square miles. It's larger than all of Earth's land area combined. You could fit all the continents into the Pacific and still have room left over. Standing on its shores, looking out toward the horizon, you're gazing across distances that dwarf anything on land. Ships can sail for weeks without seeing land. The Pacific holds secrets in its depths, ancient stories in its currents, and a grandeur that humbles anyone who truly contemplates its scale. Let's think now about something essential. Something you're doing right now without even thinking about it. Breathing. The ocean produces about half of Earth's oxygen. Every other breath you take comes from the ocean. Not from trees, not from forests, but from the sea. Tiny organisms drifting in the water, microscopic phytoplankton too small to see, are quietly photosynthesizing, turning sunlight and carbon dioxide into oxygen. Billions upon billions of these small beings working away in the sunlit surface waters, generating the air we breathe. The ocean is not just water. It's a living system, breathing life into our atmosphere, moment by moment, wave by wave. That's process. Marine photosynthesis supports life across the planet. These microscopic plants in the ocean are the foundation of the entire marine food web. Small fish eat the plankton. Larger fish eat the smaller fish. Whales, dolphins, seabirds all depend on this invisible forest of floating life, and it doesn't stop at the water's edge. The oxygen these tiny organisms produce drifts up into the atmosphere, traveling on winds, reaching inland, rising into mountains, sustaining life in deserts and cities and everywhere in between. The ocean's breath becomes the world's breath. We are all connected to these distant waters. Even when we're far from any shore, the ocean also influences global climate and weather patterns in profound ways. The water absorbs heat from the sun, stores it, and releases it slowly over time. This moderates temperatures across the globe, keeping coastal areas cooler in summer and warmer in winter. The ocean drives the water cycle, evaporating into clouds that travel across continents, bringing rain to forests and fields. Hurricanes and typhoons are born over warm ocean waters. El Niño and La Niña patterns in the Pacific affect weather worldwide, bringing droughts to some regions and floods to others. The ocean is the engine of our climate, a vast, powerful force that shapes the conditions of life on land. And how does the ocean distribute all this influence? Through ocean currents that distribute heat around the globe. Imagine great rivers flowing through the sea, some warm, some cold, all moving in vast circular patterns called gyri. The Gulf Stream carries warm water from the tropics toward Europe, making the climate there far milder than it would otherwise be. Cold water flows from the poles toward the equator, cooling tropical regions. Deep ocean currents move slowly through the abyss, taking hundreds of years to complete their journeys, carrying nutrients and heat through the darkness. These currents are like the circulatory system of our planet, moving energy and life from one place to another, maintaining balance and keeping the earth habitable now. Picture yourself standing on a beach. The water laps at your feet, then retreats. A few hours later, you notice the water has risen, or perhaps fallen. These gentle tides rise and fall due to the moon and sun. The moon, pulling on Earth with its gravity, creates a bulge in the ocean. As Earth rotates beneath this bulge, we experience high tide and low tide, the ancient rhythm of the sea. The sun contributes to, and when the sun and moon align, we get especially high and low tides, called spring tides. When they're at right angles, the tides are more moderate, called neap tides. This dance has been going on for billions of years. The moon and ocean in their eternal partnership, creating the pulse of the shore. And finally, imagine that view from the beach again, looking out across the water. The horizon at sea forms a soft, perfect curve. It's one of the most peaceful sights in nature. That gentle arc where the water meets the sky, stretching endlessly in both directions, reminds us of Earth's roundness, of the way our planet curves away beneath the ocean. On a calm day, that line is crisp and clear. In mist or rain, it softens and blurs. At sunset, it glows with color. At night, it disappears into darkness. But it's still there, that eternal curve. The edge of the world as we can see it, a reminder of how vast the ocean truly is. How much lies beyond our sight. How much beauty exists in simple, natural geometry. Let these thoughts about the ocean drift through your mind now. The endless blue waters, the breathing plankton, the currents flowing deep below, the tides rising and falling, the curved horizon. Let yourself relax into these images. The ocean is ancient, patient, and constant. And as you rest, the ocean continues its work, covering the earth, holding its waters, giving breath to the world. Let's continue our peaceful journey through the ocean's gentle rhythms. Breathe deeply, relax your body, and let these images wash over you like calm waves on a quiet shore. Imagine you're standing on a beach at dawn. The world is just beginning to wake. The sky glows softly with the first light of day, painted in shades of pink and gold. And there, stretching before you, the ocean surface can appear glassy and still. It's like looking at liquid silk, smooth and unbroken. The water reflects the colors of the sky perfectly, doubling the beauty of the sunrise. There's a hush over everything, a sense of absolute peace. The ocean at dawn has a special quality, a tranquility that feels almost sacred. The air is cool and fresh. Seabirds glide silently overhead, and that glassy surface stretches to the horizon, mirror-like, capturing the soft light, offering a moment of pure serenity before the day truly begins. But look more carefully at that seemingly still water. Even on the calmest days, you'll notice gentle swells that can travel across entire ocean basins. These aren't the crashing breakers you might think of when you picture waves. These are something more subtle, more profound. They're long, rolling undulations in the water, rising and falling so gradually that you might not even notice them unless you watch closely. These swells can travel for thousands of miles, moving through the ocean like breathing, like the slow rise and fall of a sleeping giant's chest. They were born perhaps days ago, in some distant part of the sea, and now they arrive here, carrying that distant energy, that faraway motion, all the way across the water to gently lift and lower your boat, or to eventually break softly on this shore. And here's something remarkable to contemplate. Waves can carry the memory of distant storms. That gentle swell you're watching, it might have originated in a powerful storm system hundreds or even thousands of miles away. Days ago, strong winds whipped the ocean into a frenzy, creating enormous waves. As those waves moved away from the storm, they gradually separated by wavelength. The longer, smoother swells traveled faster and farther, eventually arriving here as these peaceful, rolling motions. So even on a perfectly calm, beautiful day, the ocean is telling stories of distant weather, of storms you'll never see, of winds that blew in places you may never visit. The waves are messengers, carrying tales across the emptiness of the sea. You might look at a calm ocean and think it's completely motionless. But here's a truth worth pondering. The sea is rarely completely still, even when calm. There's always some movement, however slight. A gentle current flowing beneath the surface. A subtle shift in the water as temperature changes. The almost imperceptible pull of the tide. Tiny ripples from a passing breeze. The ocean is alive with motion, even in its quietest moments. It's never truly at rest. And there's something comforting about this, isn't there? The idea that the ocean is always in motion, always flowing, always changing, even when it appears peaceful and serene. It reminds us that stillness and motion can coexist, that peace doesn't require the absence of all movement. Yes, the ocean is always moving in slow, steady motion. Even miles below the surface, even in the deepest trenches where no light penetrates, the water is flowing. Cold water sinks and spreads along the bottom. Warm water rises. Currents circle through the basins. The ocean mixes itself over centuries, turning over slowly, like a vast, patient machine. Nothing is static. Everything flows. The water that laps at your feet has been on a journey, perhaps for decades or centuries, flowing through the depths, rising and falling, circling the globe. and it will continue that journey long after you've gone, moving in that slow, steady rhythm that has continued for millions of years and will continue for millions more. Now, let's turn our attention to the shore, to that magical place where water meets land. Beaches form as waves slowly reshape coastlines. Every wave that breaks on a beach is doing work, moving sand, shifting pebbles, carving the land. Over time, these countless waves sculpt the shore, creating the beaches we love. A beach is never finished, never permanent. It's constantly being rebuilt, grain by grain, wave by wave. Storm waves might strip sand away, carrying it offshore. Gentle waves bring it back, depositing it in new patterns. Currents move sand along the coast, creating spits and bars. The shoreline is always changing, always responding to the ocean's touch. A collaboration between land and sea that has been unfolding since the beginning, and that sand beneath your feet. It has quite a story. Sand is created grain by grain over thousands of years. Each grain was once part of something larger. A mountain, perhaps. A cliff, a boulder. Rain and wind and ice broke the rock into smaller and smaller pieces. Rivers carried those pieces to the sea. Waves ground them down further, tumbling them against each other, smoothing their edges, making them smaller and finer. Some grains are quartz from ancient granite. Some are tiny fragments of coral or shells. Each grain has journeyed here over unimaginable spans of time, shaped by countless forces, ending up here on this beach, waiting to be touched by your toes, waiting to sparkle in the sunlight, waiting to be carried somewhere new by the next tide. On certain beaches, at certain times, something magical happens. Some beaches reflect the sky like mirrors at low tide. When the tide recedes, it leaves behind a thin film of water on the hard-packed sand. If the conditions are just right, if the sand is smooth enough and the water still enough, the beach becomes a perfect mirror. You can walk across it and see the clouds reflected beneath your feet. The sky seems to extend in all directions, above and below. It's disorienting in the most beautiful way, as if you're walking through the sky itself. Photographers love these moments. Children run across the reflections, delighting in the strangeness of it. And then, slowly, the water either seeps into the sand or the tide returns, and the mirror disappears. But the memory of that magical moment remains. The receding tide reveals other wonders too. Tidal flats appear briefly before the water returns. These are expanses of sand and mud that are normally underwater but are exposed when the tide is low. They might look empty at first glance, but they're teeming with life. Small crabs scuttle across the mud. Wading birds probe the sand with their long beaks, searching for worms and clams. Shallow pools left behind are filled with tiny fish and shrimp. The tidal flats are a rich feeding ground, a productive ecosystem that exists in this in-between zone, neither fully land nor fully sea. And it's all temporary. In a few hours, the tide will return, covering everything again, and the flats will disappear beneath the waves until the next low tide reveals them once more. Finally, let's visit one more remarkable place where the ocean meets the land. Mangrove forests grow where land meets the sea. These are truly special trees, adapted to live with their roots in salt water, something most plants cannot tolerate. Mangroves grow in tropical and subtropical coastlines, their distinctive roots rising above the water like stilts or fingers. These forests are havens of life. Fish hide among the roots. Crabs climb the trunks. Birds nest in the branches. The mangroves protect the coastline from erosion and storms, their roots holding the soil in place, their trunks breaking the force of waves. They're nurseries for countless species of fish and shellfish, and they're beautiful in their own unique way. These trees standing in the water, creating a green border between land and sea, thriving in a place that seems impossible, proving that life finds a way even in the most challenging environments. Let these images drift through your mind now. The glassy dawn ocean. The gentle swells carry memories of distant storms. The beaches formed grain by grain. The mirror-like tidal flats. The mangroves stand guard where water meets earth. All of it connected, all of it part of the ocean's eternal dance with the land. Rest now in these peaceful thoughts. Let the rhythm of the waves guide you towards sleep. The ocean continues its slow work, shaping the world, moment by moment, wave by wave. We return now to those remarkable mangrove forests we visited before, standing at the edge of land and sea. But let's look closer at what happens within their tangled roots. Mangroves shelter young sea creatures. Swim beneath the surface among those arching roots and you'll find a nursery, a safe haven for countless small lives just beginning. Baby fish dart between the roots, hiding from predators. Young shrimp nestle in the shadows. Crabs find refuge in the spaces between root and mud. The complex structure of the mangrove roots creates thousands of hiding places, little pockets and crevices where small creatures can grow in safety. The young spend their earliest days here, protected, feeding on the rich nutrients that collect around the roots, growing stronger. And when they're ready, they venture out into the open ocean, but many will return, continuing the cycle. The mangroves are guardians, patient caretakers of the sea's next generation. Now, let's drift away from the shore and into slightly deeper water. Here, beneath the surface, seagrass meadows form underwater fields. Imagine meadows like those you might see on land, but submerged, swaying gently in the current instead of the breeze. Long, green blades of seagrass grow thick across the seafloor, creating underwater prairies that stretch for miles. These aren't seaweeds floating. Freely seagrasses are true plants with roots that anchor them in the sand or mud. They flower and produce seeds, just like their land-dwelling cousins. Swimming over a seagrass meadow is like flying over farmland. Seeing the geometric patterns of growth, the way the light catches the blades, the way everything moves together in the current like a choreographed dance. It's peaceful, hypnotic, a green sanctuary beneath the waves. And like the mangroves, these meadows act as nurseries for marine life. The seagrass provides shelter for the young and vulnerable. Small fish hide among the blades. Seahorses wrap their tails around the stems and wait patiently for food to drift by. Juvenile fish find rich feeding grounds here, grazing on the tiny creatures that live on the grass blades or hunting in the spaces between. Sea turtles glide through, grazing on the grass itself. The meadows are vital breeding and feeding grounds, places of abundance where life can flourish. They're also incredibly important for the ocean's health, producing oxygen, filtering the water, and capturing carbon from the atmosphere. These quiet underwater fields are working constantly to support life, both within them and far beyond. Let's venture a bit deeper now into cooler waters. Here you might encounter kelp forests that sway slowly like breathing. Kelp is a type of large brown algae that grows in dense underwater forests, primarily in cold, nutrient-rich coastal waters. Some kelp species can grow incredibly tall, up to 100 feet or more, reaching from the seafloor toward the surface where sunlight is strongest. And they move. The long, ribbon-like fronds sway back and forth with the surge and swell of the ocean, creating an underwater ballet. Swimming through a kelp forest is like walking through a cathedral. Shafts of sunlight filter down through the canopy above. Fish weave between the stalks. Sea otters wrap themselves in kelp to keep from drifting away while they sleep. Everything is in gentle motion, swaying, breathing, alive. The forest pulses with the rhythm of the sea. Now, let's travel to warmer tropical waters, where something truly remarkable happens over vast spans of time. Coral animals build reefs over long periods of time. Each coral is actually a tiny animal called a polyp, no bigger than a pencil eraser. But these small creatures do something extraordinary. They extract calcium from the seawater and use it to build hard, protective skeletons around themselves. When a coral polyp dies, its skeleton remains, and new polyps build on top of it. Generation after generation, layer upon layer, these tiny animals construct massive structures. A coral reef might be thousands of years old, built incrementally by billions and billions of polyps, each adding its small contribution. It's patient work, slow work. But over time, entire underwater cities emerge, built by creatures smaller than your fingernail, creating some of the most beautiful and complex ecosystems on Earth. And the grandest example of this patient construction, the Great Barrier Reef, is the largest coral system on Earth, stretching for over 1,400 miles along the coast of Australia. It's so large you can see it from space. It's not one continuous reef, but a collection of nearly 3,000 individual reefs and 900 islands, all built by corals over the last 20 million years. Swimming there is like entering another world, colors you've never seen, shapes beyond imagination, life in every direction. Thousands of species call the Great Barrier Reef home. It's one of the most biodiverse places on our planet, and it's all built by those tiny coral polyps, working together, building upward toward the light, creating wonder on an almost incomprehensible scale. Coral reefs do more than dazzle us with their beauty. They serve an important protective function. Coral reefs soften incoming waves. The solid structure of the reef breaks up wave energy before it reaches the shore. Large ocean swells that might crash destructively onto beaches are instead broken apart by the reef, their energy dissipated, their force. This protects coastlines from erosion and helps guard against storm damage. Communities living near reefs benefit from this natural buffer, this living breakwater. The reef asks nothing in return, simply grows, and in growing, it shelters the land. It's a reminder of how interconnected everything is, how the health of the reef affects the safety of the shore, how life in the ocean protects life on land. In these shallow tropical waters where coral thrives, shallow waters allow sunlight to reach the seafloor. This is crucial for life in these environments. Corals depend on sunlight because they have a special relationship with tiny algae that live inside their tissues. These algae photosynthesize, turning sunlight into energy, and they share that energy with the coral. Without sunlight, this partnership wouldn't work, and coral reefs couldn't exist. The same is true for the seagrass meadows we visited earlier. They need light to grow. Shallow waters are bright, illuminated worlds where photosynthesis can happen, where plants and algae can thrive, and where, as a result, countless other forms of life can flourish. The sunlight is a gift, streaming down through the clear water, bringing energy, bringing life. And that sunlight creates such beauty as it penetrates the water. Light creates drifting patterns on sandy bottoms. Have you ever noticed this? When you look down at a sandy seafloor in shallow water, you see these shifting, dancing patterns of light and shadow. They're called caustics, formed as waves on the surface act like moving lenses, focusing and defocusing the sunlight as it passes through. The patterns ripple and shimmer, constantly changing, never still. They move across the sand like living things, like light itself is dancing. It's mesmerizing to watch. You could stare at these patterns for hours, losing yourself in their gentle motion, in the interplay of light and water and sand. They're ephemeral, impossible to capture, gone in a moment and replaced by new patterns, endlessly varied, endlessly beautiful. And why does the water itself look blue? Here's something to ponder as you drift towards sleep. Water appears blue because red light is absorbed first. When sunlight enters the ocean, it contains all the colors of the spectrum. But as light travels through water, different wavelengths are absorbed at different rates. Red light, with its longer wavelength, is absorbed within just a few meters of the surface. Orange and yellow disappear next. Blue light, with its shorter wavelength, penetrates much deeper before being absorbed. So when you look at the ocean, you're seeing the blue light that has traveled through the water and bounced back to your eyes. The deeper you go, the bluer everything becomes, until at great depths, blue is the only color remaining. Eventually, even blue light fades, and you enter the eternal darkness of the deep sea. But here, in the shallows, in the sunlit zone, blue dominates, giving the ocean its characteristic color, that beautiful, peaceful blue that has inspired artists and poets and dreamers throughout all of human history. Let these underwater worlds drift through your thoughts now. The sheltering mangroves and seagrass meadows, the swaying kelp forests, the patient coral building its reef, the dancing light on the sandy bottom, the beautiful blue water was all around. Rest in these images. Let them carry you gently towards sleep. Let's drift further now, away from the coastal waters and into the vast open sea. Settle deeper into comfort. Let your breathing slow. Allow these gentle truths about the ocean to wash over you like calm waves. When you venture far from shore, far from the colorful reefs and lush kelp forests, you enter a different world. The open ocean is sometimes called the Blue Desert. At first, this might seem strange. How could the ocean, so full of water, be compared to a desert? But look around in these open waters and you'll understand. The water stretches in every direction, seemingly empty. It's a beautiful, deep blue, clear and pure, but that clarity comes from a lack of nutrients. There are no forests here, no meadows, no reefs, just endless water under the endless sky. The open ocean can feel lonely, vast, and empty. Life here is more scattered, more sparse than in the rich coastal zones. And yet, as with any desert, life persists. It's just harder to see, more patient, more adapted to scarcity. The Blue Desert has its own quiet majesty, its own subtle beauty in that seemingly infinite emptiness. But look closer. The water isn't truly empty. Tiny drifting organisms quietly fill the water. You can't see them with your naked eye, but they're there, billions upon billions of them. Microscopic algae, tiny animals no bigger than a grain of sand, larvae of creatures that will grow much larger, bacteria, single-celled organisms of countless varieties. They drift with the currents, unable to swim against the flow, living their small lives in the open water. This drifting community is called plankton, from a Greek word meaning wanderer or drifter. And though each individual is nearly invisible, together they form the foundation of ocean life. They are food for small fish, which are food for larger fish, which are food for even larger predators. Everything depends on these tiny drifters, these quiet wanderers suspended in the blue. The ocean is never truly empty. It's filled with small, patient life, and these tiny organisms do something fascinating. Plankton rise during the day and sink at night. Well, to be more precise, many types of zooplankton, the tiny animals, do this. During the night, they rise toward the surface to feed on the phytoplankton there. As dawn approaches, they sink down into deeper, darker water where they're less visible to predators. Then, as night falls again, they rise once more. This daily migration, up and down, is one of the most predictable movements in the ocean. Billions of small creatures ascending hundreds of feet as darkness comes, then descending again with the light. It's a rhythm that has continued for millions of years. A dance with the sun, a strategy for survival played out each day and night in the open sea. And they're not alone in this behavior. Many marine animals follow daily vertical migrations. Small fish follow the plankton, rising and sinking with them. Squid do the same. Even some larger creatures adjust their depth with the time of day, following food sources, avoiding predators, and responding to light levels. The ocean has layers of life that shift and move throughout the day, rising toward the surface at night when it's safer, sinking to the depths during the day when predators can see more easily. It's a vertical ecosystem, constantly in motion, constantly rearranging itself in response to the spinning of the earth and the cycle of day and night. The ocean breathes up and down, as well as back and forth. Now, let your mind return to the surface for a moment. Imagine you're on a boat in the open ocean on a calm day. You notice long, even swells rolling steadily for hours. These aren't chaotic wind waves or crashing breakers. These are smooth, rhythmic undulations, rising and falling with perfect regularity. They might come from a storm system that passed through days ago and thousands of miles away. Now they travel across the empty ocean, uninterrupted, unchanging, hypnotic. One swell passes, then another, then another. The timing is so consistent, you could almost set a clock by it. Sitting on that boat, rising and falling with these swells, you begin to feel the pulse of the ocean, the steady heartbeat of the sea. There's something deeply calming about this regularity. This proof that beneath all the chaos and variability of the ocean, there are patterns, rhythms, and reliable motions on a much larger scale. On timescales of years and decades, ocean juniors rotate slowly over years. These are enormous circular current systems that span entire ocean basins. There are 5 major gyres in the North and South Pacific, the North and South Atlantic, and the Indian Ocean. Water enters these gyres and begins a slow rotation, clockwise in the northern hemisphere, counterclockwise in the southern hemisphere, driven by wind patterns and the Earth's rotation. A piece of floating debris might take years to complete one full circle around a gyre. These are the grand highways of the ocean, the major routes that water follows as it circles the world. They're always there, always turning, patient and persistent, moving water and heat and nutrients and everything that drifts, including, unfortunately, human debris. The gyres are the slow breaths of the ocean, inhaling and exhaling over years, and there's an even larger, slower circulation pattern at work. Thermaline circulation moves water globally. Thermo refers to temperature, halin to salinity. This circulation is driven by differences in water density, which is affected by both temperature and salt content. Cold, salty water is dense and sinks. Warm, fresh water is less dense and rises. This creates a global conveyor belt of water movement. Cold water sinks in the North Atlantic and spreads through the deep ocean, traveling south around Antarctica into the Indian and Pacific basins. Gradually it warms and rises, returning eventually to the Atlantic. One complete circuit can take 1,000 years. This is the ocean's slowest breath, its deepest circulation, connecting all the ocean basins, mixing the waters of the world over millennia. Within the water column itself, layers of warm and cool water stack gently. The ocean isn't a uniform temperature from top to bottom. The sun warms the surface, creating a layer of warm water that floats on top of cooler, denser water below. Between these layers is a transition zone called a thermocline, where temperature drops rapidly with depth. You can sometimes feel this while swimming yaw in warm water. Then you kick down and suddenly it's cold. These layers are relatively stable. The warm water stays on top, the cold water below. They don't mix easily. The ocean is stratified, organized into distinct layers, each with its own temperature, its own density, its own community of life. It's a layered cake of water built by temperature and salt, structured by the laws of physics. But the ocean has secret motions too. Things happening beneath the surface that you'd never know were there unless you had special instruments. Internal waves move invisibly beneath the surface. Unlike the waves we see breaking on beaches, internal waves occur at the boundaries between water layers of different densities, especially at the thermocline. They can be enormous, hundreds of feet tall, but because they occur underwater. At the boundary between layers, you can't see them from above. They move slowly through the ocean interior, up and down, transferring energy, mixing water, affecting submarines and underwater installations. They're ghost waves, invisible giants moving through the deep. A reminder that the ocean has hidden dynamics, secret motions, mysteries that exist beyond our direct perception. And here's something that might surprise you as you drift towards sleep. Sound travels faster underwater than in air. Much faster, in fact about 4 times as fast. In air, sound travels at around 760 miles per hour. In water, it travels at about 3,400 miles per hour. This means that sound can travel great distances through the ocean. Whales can hear each other across entire ocean basins. A sound made on one side of the ocean can be detected on the other side, traveling through the water, barely diminishing. The ocean is full of sound clicks and whistles from dolphins, songs from whales, the snapping of shrimp, the rumble of underwater earthquakes. It's a sonic landscape we rarely experience, but it's there, always. A world of sound traveling quickly through the blue, connecting distant creatures, filling the water with invisible messages. Let these images of the open ocean settle into your mind now. The blue desert filled with drifting life. The daily migrations up and down through the water. The long, steady swells. The slow gyres turning. The layers of water stacked gently. The invisible waves moving in the deep. The sound travels quickly through the blue. All of it connected, all of it moving, all of it part of the ocean's vast, patient system. Rest now in this knowledge. The ocean continues its ancient rhythms, whether we watch or not. Let yourself drift with these thoughts, like plankton in the current, peaceful and weightless. Sleep well. Let's continue our journey through the ocean's peaceful mysteries. Let yourself relax completely now. Breathe slowly and deeply. Allow these gentle truths to guide you into deeper rest. We explored in our last segment how sound travels faster underwater than in air. Let's stay with that thought for a moment longer, because it reveals something beautiful about the ocean's hidden nature. Imagine you're diving beneath the surface, suspended in that blue world, and you're listening. What you hear is quite different from the silence you might expect. The ocean is not a quiet place. It hums with life, with movement, with sound traveling quickly through the water from near and far. You might hear the distant call of a whale, traveling hundreds of miles to reach your ears. The clicking of dolphins communicating, the grinding sound of parrotfish eating coral, even the crackling symphony of snapping shrimp, countless tiny sounds combining into a chorus. And beneath it all, distant waves create constant background noise. The crashes and breaks of waves far away, the rumble of storms on the horizon, all of it traveling through the water, creating a subtle, ever-present soundtrack to the underwater world. It's a kind of white noise, soothing in its consistency. A reminder that the ocean is always in motion somewhere. On the surface of this vast ocean, floating in the open water, you might encounter something unexpected. Buoys drift quietly while measuring ocean conditions. These floating instruments bob gently with the waves, unattended, patient, doing their work day and night. They measure water temperature, salinity, wave height, air pressure, wind speed. Some send their data by satellite to scientists on distant shores. Others store it internally, waiting to be retrieved. They drift with currents or remain anchored in one spot, lonely sentinels in the blue desert, quietly observing, constantly recording. There's something peaceful about these buoys, these small human presences in the vast ocean, bobbing up and down with the swells, weathering storms, bleached by the sun, doing their simple job without complaint. They connect us to the ocean, bringing us information, helping us understand the sea's moods and patterns. And sometimes, drifting alongside these buoys, you might find something else. Seaweed mats float calmly far from shore. These aren't rooted seaweeds like kelp growing from the bottom. These are floating rafts of algae, sometimes called sargassum, drifting across the open ocean. Some of these mats can be enormous, stretching for miles, visible from space. They provide a rare habitat in the open water, a floating island of sorts. Small fish hide beneath them, finding shade and shelter. Crabs cling to the fronds. Turtles rest on the surface near them. These drifting gardens are entire ecosystems, moving slowly with the currents, traveling across ocean basins, never touching land, floating free under the open sky. They're strange and wonderful, these nomadic forests, never quite belonging to any shore, eternally wandering the blue dot in these same open waters. You might encounter one of the ocean's most magnificent creatures. Whale sharks cruise slowly near the surface. Despite their name, whale sharks are sharks, not whales, but they're gentle giants. They're the largest fish in the ocean, growing up to 40 feet long or more. Yet they feed on some of the smallest creatures, plankton and tiny fish. They swim slowly, mouths open wide, filtering vast amounts of water, straining out their microscopic food. Watching a whale shark is a meditation in itself. They move with such grace, such unhurried purpose. Their spotted skin catches the light. Their enormous tail sweeps slowly back and forth. They seem almost philosophical in their slowness, ancient and wise, unbothered by the rushing world, moving at their own peaceful pace through the blue. Swimming alongside one is a privilege, a moment of connection with something vast and gentle and utterly calm. The ocean is full of journeys, of migrations both small and grand. We've spoken of the daily vertical migrations of plankton, but some journeys are on an altogether different scale. Sea turtles migrate thousands of miles across oceans. A turtle might nest on a beach in Japan, then swim all the way across the Pacific to feed off the coast of California. Another might be born on a beach in Florida, spend years in the open Atlantic, then return decades later to that same beach to lay her own eggs. How they navigate these vast distances is still something of a mystery. They might use the Earth's magnetic field, the position of the sun, the smell of the water, or some combination of these. But navigate they do, crossing entire ocean basins, swimming steadily, patiently, for months at a time, driven by ancient instincts, following invisible roads through the blue. Their journeys are epic poems written in salt water, stories of endurance and return. Now, let's begin a different kind of journey. Not horizontal across the ocean's surface, but vertical, downward into the depths. The ocean has distinct light zones, layers defined by how much sunlight can penetrate. At the surface, in the sunlit zone, light is abundant. This is where we've spent most of our time, in the bright, warm, well-lit waters where photosynthesis happens and life flourishes. But as you descend, the light begins to fade. The vibrant colors disappear. First reds and oranges vanish within the first 30 feet. Deeper still, yellows and greens fade away. By the time you reach about 600 feet down, you've entered a different realm, a place of perpetual dimness. Here, the twilight zone receives very little sunlight. It's not quite dark, but it's not bright either. It's a zone of shadows and faint blue light filtering down from above. This is a strange, in-between world. Some light still penetrates, just enough to make out shapes, just enough for vision to be useful, but not enough for plants to photosynthesize. Many creatures here have adapted in fascinating ways. Some are transparent, nearly invisible. Others have enormous eyes to capture every photon of available light. Many possess bioluminescence, the ability to create their own light through chemical reactions in their bodies. They flash and glow in the dimness, creating their own stars in the twilight. It's a quiet zone, less populated than the surface, but full of strange beauty, a place of perpetual dusk where the sun is only a faint memory. But continue descending, and you leave even this faint light behind. Below that, darkness becomes constant. At about 3,000 feet, you enter the midnight zone, where no sunlight penetrates at all. None. The darkness here is absolute, more complete than any darkness you've experienced on land. There are no shadows, because there is no light to cast them. It's an eternal night, a blackness so profound it's almost a physical presence. And yet, even here, there is light, the bioluminescence of deep-sea creatures. Fish with glowing lures dangling in front of their mouths. Jellyfish that pulse with light. Squid that can create light shows across their bodies. In the absolute darkness, these creatures make their own light, for hunting, for communication, for defense. It's a world of living stars in infinite black, and it's cold in these depths. Many deep-sea animals live near freezing temperatures. The sun's warmth doesn't reach here. The water hovers just a few degrees above the freezing point of salt water, around 35 to 39 degrees Fahrenheit. Life here moves slowly, conserving energy in the cold. Metabolisms run at a fraction of the speed of surface creatures. Everything is patient, quiet, still. The cold is constant, unchanging, a fact of existence. These creatures have never known warmth. They've evolved in the cold and the dark, perfectly adapted to conditions that would kill most surface life. There's something humbling about this, about life persisting in such an extreme environment, proof that life is remarkably resilient, remarkably creative. And there's one more factor that makes the deep ocean so extreme. Pressure increases hundreds of times below the surface. At sea level, you experience 1 atmosphere of pressure, the weight of all the air above you. But water is much heavier than air. For every 33 feet you descend in the ocean, the pressure increases by 1 atmosphere. By the time you reach the deepest parts of the ocean, around 36,000 feet down in places like the Mariana Trench, the pressure is over 1,000 times greater than at the surface. It's crushing, unimaginable pressure, and yet creatures live there. Fish, shrimp, even tiny organisms, all adapted to withstand this incredible force. Their bodies are built differently, with special proteins and cellular structures that function under pressure. They couldn't survive being brought to the surface. The pressure drop would be fatal. They belong to the depths as surely as we belong to the air. Let these thoughts of the deep ocean settle over you now. The sound traveling through the water. The buoys drifted peacefully. The slow whale sharks and the journeying turtles. The zones of light fading to twilight, fading to absolute darkness. The cold and the pressure of the deep. All of it is part of the ocean's vast geography, its three-dimensional landscape of depths and distances. Rest now. Sink gently into sleep, like descending peacefully into calm, dark water. The ocean holds you. The ocean surrounds you. Let yourself drift down into rest. Let's continue our peaceful descent into the ocean's deepest realms. Relax completely now. Let go of any remaining tension. Simply breathe and listen as we explore the quiet wonders of the deep. We spoke last of the crushing pressure in the deep ocean, pressure that would destroy most forms of life. And yet, despite pressure, delicate animals thrive. This seems impossible at first. How can something fragile exist where the weight of the water above would crush a submarine? But life has found a way, as it always does. Deep-sea creatures don't have air pockets inside them that would be compressed. Their bodies are filled with water and incompressible tissues. The pressure inside their bodies equals the pressure outside, so they don't feel crushed at all. And so you find delicate things in the depths, translucent jellies, paper-thin fins, gossamer tentacles. They drift through the darkness, fragile as tissue paper, surviving where solid metal would crumple. It's a beautiful paradox, strength through adaptation rather than through armor, resilience in unexpected forms. Among the most delicate and most common creatures of the deep, jellyfish drift slowly in deep water. They're everywhere in the ocean, at every depth, but in the darkness of the deep sea, they take on an otherworldly quality. Many deep-sea jellyfish are bioluminescent, glowing faintly as they drift. Some are transparent, visible only by their ghostly glow. Others trail long, delicate tentacles that can extend for dozens of feet, fishing the water for prey. They move without effort, without swimming in any directed way, simply pulsing gently, drifting with the current, floating through the black water like phantoms. Watching them is hypnotic, the slow pulse of their bells, the graceful trailing of their tentacles, the soft bioluminescent glow. They're like living constellations, drifting through an underwater sky, and they're not alone in their ability to create light. Some deep-sea animals glow softly in the dark. We touched on this before, but it's worth dwelling on. In a world without sunlight, bioluminescence becomes vital. It's used for hunting anglerfish dangle glowing lures to attract prey. It's used for defense. Some creatures produce clouds of glowing particles to confuse predators. It's used for communication. Many animals flash patterns at each other, sending signals through the darkness. The deep ocean twinkles with these small lights, a galaxy of living stars. If you could visit the deep sea with your lights off, you'd see these gentle glows appearing and disappearing, pulsing and flashing, creating a light show in the eternal night. It's proof that even in the darkest places, life finds ways to shine. Now, imagine you're suspended in this dark water, hovering, motionless. If you wait long enough, you'll notice something peculiar. Small particles are falling past you, drifting down like snow. Marine snow falls gently through the water. These aren't snowflakes, of course, but tiny particles, dead plankton, fecal matter from animals above, bits of deteriorating tissue, clumps of bacteria, fragments of all kinds. They drift down through the water column, slowly, steadily, like a gentle, never-ending snowfall. This marine snow is crucial for deep-sea life. It's food, drifting down from the sunlit world above, feeding creatures that could never reach the surface. It settles on the seafloor, layer upon layer, building up over time. It connects the surface to the depths, a constant rain of nutrients falling through the darkness, sustaining life in the abyss. And this process takes time. So much time. Fine sediments take thousands of years to settle. The smallest particles fall incredibly slowly through the water. A speck of clay might sink at a rate of only a few feet per day. At that speed, it could take years for a single particle to drift from the surface to the deepest ocean floor. Thousands of years for the finest sediments. They spiral slowly down through the water, through zones of light and twilight and darkness, through warm surface waters and cold depths, taking an impossibly slow journey to the bottom. By the time they arrive, the world above has changed. Civilizations have risen and fallen. Ice ages have come and gone. And still the particles drift down, patient, unhurried, adding to the layers below. And those layers tell stories. Deep sea floor mud records ancient history. The sediment on the ocean floor is like a book, each layer a page from the past. Scientists can extract cores of this sediment, bringing up columns of mud that represent millions of years. In these layers are fossils of ancient plankton, their shells settling down through the ages. Chemical signatures that reveal past ocean temperatures. Volcanic ash from eruptions long ago. Even dust blown from distant continents. By reading these layers, we can understand what the climate was like millions of years ago. How ocean currents have changed when ice ages occurred. The mud remembers everything. It's an archive of Earth's history, written in settling particles, preserved in the cold and dark at the bottom of the sea. On this deep seafloor, scattered across the mud, you might find something strange. Manganese nodules grow over millions of years. These are roughly spherical rocks, ranging from pebble size to potato size, lying on the seafloor. They form when minerals precipitate out of the seawater very, very slowly, layer by microscopic layer, building up around a nucleus, maybe a shark's tooth, maybe a fragment of shell. They grow at a rate of perhaps a few millimeters per million years. That's almost impossibly slow. A nodule the size of your fist might be 50 million years old. Think about that. 50 million years of patient mineral deposition, layer by infinitesimal layer, lying on the seafloor, waiting. They carpet some areas of the deep ocean, fields of these dark stones, each one recording unimaginable spans of time in its layers. And there are living things that rival even these stones in their longevity. Some deep-sea corals live for thousands of years, unlike their shallow water cousins that rely on sunlight and algae. Deep-sea corals survive in darkness, feeding on marine snow and whatever else drifts down. They grow incredibly slowly, adding perhaps millimeters per year. A deep-sea coral the size of a person might be 4,000 years old, as old as the pyramids, older than any written language. They've been growing in the dark since before recorded history, slowly, patiently, building their skeletons, hosting communities of other creatures. Their living libraries, their growth rings recording changes in ocean chemistry over millennia. To encounter one is to meet something ancient, something that has persisted through vast sweeps of human history, quietly growing in the cold and dark. The deep seafloor isn't entirely flat. In many places, seamounts rise silently from the seafloor. These are underwater mountains, extinct volcanoes that grew from the seafloor but never quite reached the surface. They rise thousands of feet, sometimes coming within a few hundred feet of the surface, sometimes staying entirely submerged. They dot the ocean floor, solitary peaks or chains of mountains, silent and unseen. Currents strike these seamounts and are forced upward, bringing nutrients from the deep toward the surface. This makes seamounts hotspots of marine life. Fish gather around them, corals grow on their slopes, whales visit them to feed. They're oases in the deep islands that never break the surface, yet teeming with life. And when seamounts occur in chains, they create something remarkable. Seamount chains act as stepping stones for life. Species can spread from one seamount to the next, hopping across the deep ocean basin. A coral larva might settle on one seamount, and its offspring might drift to the next one down the chain. Over time, populations spread, gene flow occurs, and the seamounts become connected by life, a chain of underwater islands linking distant parts of the ocean. These chains might stretch for thousands of miles, created by tectonic hotspots as plates move over them like the Hawaiian Islands. Each seamount in the chain is a refuge, a haven, a stepping stone. They connect the ocean in invisible ways, creating highways for life through the deep. Let these images of the deep ocean settle into your mind now. The delicate jellies drifting in the dark, the gentle marine snow falling through the water, the ancient mud recorded millions of years ago. The corals have been growing for thousands of years, the silent seamounts rising from the floor. All of it moving slowly, changing slowly, existing in deep time, in patient darkness. Rest now in this deep place. Let yourself sink into the profound stillness of the ocean floor. Nothing rushes here. Everything is patient. Everything is calm. Sleep deeply. Sleep well. Continue to rest peacefully as we explore more of the ocean's hidden geography. Let your body sink deeper into relaxation. Breathe slowly. Allow these gentle truths to guide you further into calm. The seafloor is not flat and featureless. It has a geography as complex as any landscape on land, with mountains and valleys, ridges and canyons. and these features shape the ocean in profound ways. Underwater ridges guide ocean currents, just as wind flowing over mountains on land is deflected and channeled. Ocean currents flowing across the seafloor are shaped by the ridges beneath. A current encounters a ridge and must flow around it or over it, changing direction, speeding up or slowing down. These ridges act like guardrails, keeping currents on certain paths, preventing them from spreading randomly across the ocean floor. They create highways for deep water, channels that water follows for thousands of miles. The ocean's circulation is sculpted by this hidden topography, shaped by mountains we rarely think about, guided by ridges we cannot see, and just as there are ridges, there are also valleys. Underwater canyons can be deeper than land canyons. The Grand Canyon is a mile deep, an impressive chasm carved by the Colorado River, but there are submarine canyons that dwarf it. The Monterey Canyon off the coast of California is deeper than the Grand Canyon and just as dramatic, with steep walls dropping thousands of feet. These canyons were carved partly by rivers during ice ages when sea level was lower, and partly by underwater landslides and turbidity dense flows of sediment-laden water that rush down the continental slope. These canyons channel nutrients from the continental shelf down into the deep sea. They're conduits for sediment, pathways for strange deep-sea currents. And they're hauntingly beautiful, though few have ever seen them. Steep-walled valleys hidden beneath the waves, with all we've learned about the ocean, with all our technology and all our curiosity, here's a humbling truth. Only a small fraction of the ocean has been explored. We've mapped the surface of the Moon and Mars in greater detail than we've mapped our own ocean floor. Fewer people have visited the deepest parts of the ocean than have walked on the Moon. Vast areas of the seafloor have never been seen by human eyes. We know they exist. We know roughly what the topography looks like from sonar mapping. But we haven't sent cameras there, haven't collected samples, haven't studied the life that exists there. The ocean remains largely mysterious, largely unknown. It's both sobering and exciting sobering, because we've neglected this vast part of our own planet. Exciting because there's still so much to discover, so many secrets waiting, and this means that many species remain undiscovered. Every year, scientists describe hundreds of new marine species. Every deep-sea expedition brings back creatures that have never been seen before. Strange fish with bizarre adaptations, jellies that glow in colors we didn't know existed, worms living in impossible places, crustaceans with forms that seem invented by an alien imagination. How many species are out there, living in the deep, that we know nothing about? Thousands, certainly. Perhaps tens of thousands, perhaps more. Each one with its own story of adaptation, its own strategy for survival, its own place in the ecosystem. They've been living their lives for millions of years, evolving, adapting, persisting, and we've never known they existed. The deep sea remains largely unknown, a wilderness on our own planet, full of life we're only beginning to understand. Now let's explore one of the ocean's grandest features, though it's entirely hidden beneath the waves. The mid-ocean ridge is Earth's longest mountain range. It stretches for more than 40,000 miles, wrapping around the globe like the seam on a baseball. It runs through the Atlantic, the Indian Ocean, the Pacific, and yet most people have never heard of it. That's because it's entirely underwater, hidden beneath miles of water, out of sight, out of mind. This ridge is where a new ocean floor is born. Magma rises from the Earth's mantle, erupts at the ridge, and solidifies into new rock. The seafloor spreads away from the ridge in both directions, slowly, steadily, at a rate of 1 inch or 2 per year. The mid-ocean ridge is the most active volcanic system on Earth, constantly producing new crust, and yet it does its work in darkness and silence, unseen, patient, persistent. In places, this volcanic activity breaks the surface. Many ocean islands are volcano peaks. Hawaii, Iceland, the Azores, the Galapagos, all of them are the tips of enormous volcanic mountains rising from the seafloor. What we see as an island is just the summit. Below the water, these mountains are massive, rising thousands or even tens of thousands of feet from the ocean floor. Mauna Kea in Hawaii, measured from its base on the seafloor to its summit, is taller than Mount Everest. We think of these islands as small places, and on the surface they are, but beneath the waves they're giants. They're proof of the powerful forces at work beneath the ocean, the restless energy of the earth constantly building new land, constantly reshaping the seafloor. And just as there are ridges where new crust is created, there are trenches where old crust is consumed. Deep trenches are among the most remote places on Earth. These are the deepest parts of the ocean, places where one tectonic plate is sliding beneath another, creating a long, narrow chasm. The Mariana Trench, the deepest of them all, plunges nearly 7 miles below the surface. The pressure there is crushing, the temperature near freezing, the darkness absolute. It's more remote, in a sense, than the moon. It's harder to reach, harder to explore. Only a handful of people have ever visited the deepest point. It's a place of extremes, a place at the very limit of where life can exist on our planet. And yet, life does exist there, adapted to conditions that seem impossible. These trenches are so remote, so difficult to reach, that few expeditions have ever mapped some trenches. We know where they are, roughly how deep they go, but the detailed exploration is only just beginning. There are trenches in remote parts of the Pacific that have been visited perhaps once, perhaps never. The technology required to withstand the pressure to operate in such depths is incredibly challenging to build. Each expedition is expensive, complex, and time-consuming, so the trenches remain mostly unexplored, mysterious, and waiting. Who knows what lives there? What strange creatures, what unusual geology, what secrets are hiding in those deepest places? Let's return now to something we touched on earlier, but it deserves more attention. Remember the thermaline circulation, that global conveyor belt of ocean water. One of the most important sources of deep water in that system is the Antarctic. Antarctic bottom water spreads slowly worldwide. In the waters around Antarctica, the ocean gets extremely cold. When sea ice forms, salt is left behind in the water, making it even denser. This cold, salty, dense water sinks all the way to the bottom and then begins spreading outward, flowing along the seafloor, moving northward into all the ocean basins. It's the coldest, densest water in the ocean. It moves slowly, very slowly, creeping along the bottom at a rate of perhaps a few inches per second. But over decades and centuries, this Antarctic water reaches every corner of the world's oceans. It fills the deepest basins, influences the chemistry of the deep sea, and helps drive global circulation. It's a slow but powerful force, this cold water from the bottom of the world, spreading silently through the depths, connecting Antarctica to everywhere. Let these images of the ocean's hidden geography settle over you now. The ridges guiding currents in the dark. The canyons are deeper than any on land. The vast unexplored spaces full of undiscovered life. the longest mountain range on Earth, hidden beneath the waves. The volcanic islands with their roots in the deep. The remote trenches, Earth's deepest places. The cold Antarctic water spreads slowly, silently, across the world. There is so much we don't know. So much is still hidden. So much is still waiting to be discovered. And that's all right. The ocean keeps its secrets. It moves at its own pace. It follows its own ancient rhythms. And we can rest in that mystery, in that unknowing, in that vastness beyond our full comprehension. Let yourself drift now, like that Antarctic water, slow and steady, spreading into rest. The ocean continues its patient work, and you can simply let go, sleep deeply, sleep peacefully. Let's continue our peaceful journey through the ocean's deepest mysteries. Settle even more deeply into rest now. Let your breathing become slower, quieter. Allow these gentle truths to carry you further into calm. We spoke last of Antarctic bottom water spreading across the world. Let's linger on that thought for a moment. This water can take centuries to travel. Imagine a drop of water sinking to the seafloor near Antarctica. It begins its slow journey along the bottom, creeping northward at a pace barely perceptible. Years pass. Decades. That same drop of water is still moving, still traveling, flowing through trenches, around seamounts, across vast abyssal plains. A century passes, then 2 centuries, and still that water continues its journey. It might take 500 years, even 1,000 years, for that Antarctic water to reach the North Pacific. By the time it arrives, civilizations have risen and fallen. Technologies have been invented and become obsolete. And yet the water continues, patient, unhurried, following the ancient pathways of the deep, moving in timescales that dwarf human experience. The deep ocean holds other strange phenomena, things that seem impossible until you understand the physics. Brine pools form underwater lakes on the seafloor. Yes, lakes under the ocean. How can this be? When salt deposits beneath the seafloor dissolve, they create water that's much saltier than the surrounding ocean. This brine is denser and doesn't mix easily, so it collects in depressions on the seafloor, forming actual pools with distinct shorelines. You could be in a submarine, traveling along the bottom, and suddenly encounter a lake, complete with a surface and waves. These brine pools are toxic to most life, but some bacteria thrive at their edges. They're eerie, beautiful, and utterly strange lakes within the ocean. Pools within the water, boundaries between 2 different liquids, each maintaining its own integrity. In other parts of the seafloor, something else seeps up from below. Cold seeps release ancient water slowly. These are places where water that has been trapped in sediments, sometimes for millions of years, gradually percolates up through the seafloor. This water brings with it methane and other chemicals from deep within the earth. The methane feeds specialized bacteria, which in turn support entire ecosystems, clams, mussels, tube worms, all thriving on the chemical energy seeping from below rather than on sunlight from above. These cold seeps are oases in the deep, communities built on ancient water and ancient chemistry, sustained by the slow release of substances from the Earth's interior. They're proof that energy for life can come from unexpected places, that ecosystems can thrive without light, without photosynthesis, fed instead by the planet's own slow exhalations. And the ocean has yet another wonder hidden in its depths, something that seems to defy logic. Underwater waterfalls flow over seafloor slopes. These aren't waterfalls in the traditional sense. It's all water, after all. But when cold, dense water encounters an underwater cliff or slope, it pours over the edge like a waterfall, flowing down into the basin below. The Denmark Strait Cataract, between Iceland and Greenland, is the largest of these underwater waterfalls. Cold water from the Nordic seas cascades over an underwater ridge and plunges more than 2 miles down to the seafloor, carrying 15 million cubic meters of water per second, more than 1,000 times the flow of Niagara Falls. It's invisible from above, silent, immense, a waterfall of water within water, one of the ocean's grandest but most hidden features. Over vast stretches of time, life itself builds the seafloor. Plankton shells form chalky layers over millennia. Remember those tiny plankton drifting near the surface, some of them with shells made of calcium carbonate. When they die, their shells sink, joining the marine snow drifting down through the water column. On the seafloor, they accumulate, shell after tiny shell, layer after microscopic layer, building up over thousands and millions of years. In some parts of the ocean, the seafloor is covered in a soft white or cream-colored sediment called calcareous ooze, made almost entirely of these plankton shells. It can be hundreds of feet thick, representing millions of years of patient accumulation. Walk on this seafloor and you'd be walking on the remains of countless tiny lives, on a graveyard of plankton that lived their brief lives in the sunlight above, then settled into eternal darkness below. And in this way, ocean basins quietly store Earth's history. The sediments on the seafloor are archives, libraries written in mud and shell and dust. Each layer tells a story: what the climate was like when it was deposited, what creatures lived in the water above, whether there were volcanic eruptions or ice ages or periods of abundant life. Scientists drilling into these sediments can read backwards through time, learning about ancient oceans, ancient climates, the evolution of life. The ocean floor remembers everything. It's patient, silent, and complete in its record keeping. While we live our brief lives on the surface, the ocean floor accumulates its layers, storing information, preserving the past, building an archive that future generations or, perhaps, other species might one day read and understand. The ocean does more than record history. It actively shapes our present and future. The ocean acts as a carbon sink. It absorbs carbon dioxide from the atmosphere, pulling it down into the water. This is one of the most important services the ocean provides. Without it, the level of carbon dioxide in our atmosphere would be much higher than it already is. The ocean absorbs this gas through the simple process of gas exchange. At the surface, carbon dioxide dissolves into the water. Phytoplankton also help by using carbon dioxide for photosynthesis, then sinking when they die, carrying carbon to the deep. The ocean is quietly working to balance the atmosphere, to moderate the effects of our emissions, absorbing year after year, storing carbon in its depths. More specifically, it absorbs large amounts of carbon dioxide. We're talking about billions of tons of carbon dioxide absorbed by the ocean each year. About a quarter of all the carbon dioxide we emit is absorbed by the ocean. That's an enormous amount, a crucial buffer between our emissions and the atmosphere. But this absorption comes at a cost. The carbon dioxide makes the ocean more acidic, which affects marine life, particularly creatures with shells or skeletons made of calcium carbonate. Still, the ocean continues to absorb, continues to moderate, and continues to help regulate the Earth's chemistry. It's a massive, planetary-scale service, happening silently, invisibly, at the boundary between air and water. And through this and other mechanisms, the deep ocean helps regulate Earth's climate. The ocean stores heat, transports it around the globe through currents, releases it slowly over time. It moderates temperature extremes, keeping the planet more stable and habitable than it would otherwise be. The carbon it absorbs helps control greenhouse gas levels. The water it evaporates drives weather patterns and distributes fresh water across continents. The ocean is the thermostat of the Earth, the great stabilizer, the planetary scale system that keeps things in balance. And it does this work constantly, reliably, without fanfare or recognition. We take it for granted, but we shouldn't. The ocean's role in regulating climate is fundamental to our survival. And remember, these processes occur slowly and silently. The water takes centuries to circulate. The plankton shells accumulate over millennia. The carbon is absorbed day by day, year by year, building up in the deep. Climate regulation happens through countless small interactions, adding up over time. Nothing about the ocean is rushed. Everything operates on scales of years, decades, centuries, eons. The ocean is patient. It works in deep time. It changes slowly. It responds gradually. There's something profoundly calming about this, isn't there? In a world that often feels too fast, too urgent, too immediate, the ocean reminds us that the most important processes are slow. That patience is powerful. That slow work, done consistently over time, shapes the world. Let these thoughts of the ocean's patient work settle over you now. The water traveled for centuries. The brine pools and cold seep. The underwater waterfalls. The plankton shells are accumulating. The carbon being absorbed. The climate is being regulated. All of it happening slowly, silently, without hurry, without stress. You can be like the ocean now, slow, patient, at peace. Let yourself settle into rest as gently as marine snow settling to the sea floor. Let your thoughts slow like the deep currents. Let yourself drift into sleep as naturally as the ocean cycles its water. Rest now. The ocean continues its work, and you can simply let go, sleep deeply, sleep well. Let's return now to the ocean's surface, to witness the gentle rhythms and quiet beauty found where water meets air. Breathe deeply and slowly. Let yourself sink even further into relaxation. Simply listen and drift. We've spoken before about the tides, those ancient rhythms of rising and falling water. Let's explore them a bit more deeply now. Moon phases subtly affect ocean tides. You probably know that the moon causes tides, but the phase of the moon matters too. When the moon is full or new, it aligns with the sun and their gravitational pulls combine, creating especially high tides and especially low tides called spring tides. When the moon is at first quarter or third quarter, the sun and moon are at right angles, partially cancelling each other out, creating more moderate tides called neap tides. These changes happen gradually, predictably, following the moon's monthly cycle. Watching the tides over the course of a month, you'd see them grow and shrink, responding to that distant gravitational dance between Earth, Moon, and Sun. It's subtle, gentle, a cosmic influence felt in the rise and fall of water at your feet. As the tide changes, something interesting happens. Tidal currents reverse direction gently. In narrow channels, bays, and estuaries, the tide doesn't just rise and fall. Vertically it flows in and out horizontally, creating tidal currents. As the tide rises, water flows in, sometimes quite strongly. Then, at high tide, the current pauses, a moment called slack tide. Then, as the tide begins to fall, the current reverses, flowing back out. This happens twice a day in most places, a gentle back and forth, in and out, like the ocean breathing. If you anchor a boat in a tidal current, you'll watch it slowly swing around as the current reverses, reorienting itself to the new flow. It's a peaceful transformation, water changing its mind, flowing the other way, patient and inevitable. In certain places, geography amplifies these tides in remarkable ways. Some bays amplify tides smoothly and predictably. The Bay of Fundy in Canada is famous for having the highest tides in the world, with differences between high and low tide reaching over 50 feet in some spots. The shape of the bay funnels the tidal water, concentrating it, causing it to pile up as it moves into the narrowing bay. Other bays and estuaries have similar but less extreme effects. The tide comes in, the water level rises dramatically. Boats that were resting on mud are suddenly floating, and then, hours later, it all reverses. These amplified tides are entirely predictable, following the same astronomical influences, just magnified by local geography. It's a beautiful example of how the shape of the land and the behavior of water interact at the edges of the ocean. Where land slopes gently to meet the sea, you find special ecosystems shaped entirely by the tides. Salt marshes flood and drain quietly each day. These are coastal wetlands covered with grasses and reeds that are submerged at high tide and exposed at low tide. Twice a day, the ocean flows in, covering the marsh in a few feet of water, bringing nutrients, bringing small fish and crabs. Then the tide recedes, and the marsh drains, leaving mudflats and shallow pools. The plants here are specially adapted to tolerate both salt water and air, both submersion and exposure. Walking through a salt marsh at low tide, your feet sink into the soft mud, and you can hear the gentle gurgling of water draining through tiny channels. At high tide, the same marsh becomes a quiet, shallow sea, barely moving, soaking in sunlight. It's a place of transformation, changing twice daily, forever caught between land and ocean. Where rivers meet the sea, another kind of mixing occurs. River water blends slowly with seawater. Fresh water from the river is less dense than salt water, so it tends to float on top, creating a layered system. As the fresh water flows out to sea and the tide brings salt water in, they gradually mix. The transition zone, where fresh and salt water mingle, is called an estuary. The salinity changes gradually from purely fresh upstream to purely salty at the ocean. Fish and other creatures move through this gradient, finding the salinity that suits them best. The mixing is gentle, gradual, taking time and distance. Nutrients from the river meet the productivity of the sea, making estuaries some of the most biologically rich environments on Earth. It's a blending, a meeting place, where two worlds merge slowly. On the ocean surface itself, patterns emerge. The ocean surface sometimes forms foam lines. If you've spent time at the beach or on a boat, you've probably noticed these long, wandering lines of foam or debris stretching across the water. They form where currents converge, where two bodies of water moving slightly differently meet and push floating material together. Foam, bits of seaweed, pieces of driftwood, all collect along these convergence zones, creating visible lines across the surface. These lines can stretch for miles, meandering across the sea. Seabirds know about them and often gather along them because fish and other prey also concentrate there. These foam lines are signatures of the ocean's surface currents, making visible the invisible flow of water. Related to this, windrows are lined softly across the sea. When wind blows steadily across the ocean, it creates not just waves, but also subtle circulation patterns in the surface water. These patterns organize debris, foam, and plankton into parallel lines running in the direction of the wind. From a boat, you see these soft stripes across the water, alternating between clearer water and lines of accumulated material. From the air, they're even more striking, creating a combed appearance across the ocean's surface. These windrows are gentle, ephemeral, changing as the wind changes, always organizing the surface into these soft parallel patterns. They're evidence of the wind's touch on the water, written in foam and floating particles. Now imagine it's night, and you're swimming in warm tropical waters. As you move your hand through the water, something magical happens. Bioluminescent plankton can glow when disturbed. These are tiny dinoflagellates, single-celled organisms that produce light through a chemical reaction when they're swim through a dense patch of them, and your body leaves a trail of blue-green sparkles. Every movement creates light. Splash the water, and you create an explosion of tiny stars. It's like swimming through the night sky, through liquid starlight. This bioluminescence likely evolved as a defense mechanism. The sudden flash of light might startle predators. But for us, it's pure magic, one of the ocean's most enchanting displays, and the glow appears calm and fleeting. The light produced by each dinoflagellate lasts only a fraction of a second, flashing briefly then fading. But when billions of them flash together in response to a wave or a swimming fish, it creates a sustained glow that seems to flow across the water. Then, as the disturbance passes, the glow fades and darkness returns. It's ephemeral, impossible to capture, gone almost as soon as it appears. This fleeting quality makes it even more precious. You can't hold on to it, can't preserve it. You can only witness it in the moment, then carry the memory. It's a gift the ocean gives briefly, then takes back. In colder waters, other ethereal phenomena occur. Sea smoke forms when cold air meets warm water. On a cold morning, when the ocean is warmer than the air above it, water evaporates from the surface and immediately condenses into fog, creating wisps and columns of mist rising from the water. It looks like the ocean is steaming, smoking, breathing visible breath into the cold air. The fog rolls and swirls, rising up, dissipating, reforming. It can be so thick that it obscures everything, or so light that it's just a ghostly veil. Either way, it's hauntingly beautiful, the ocean exhaling into winter air, creating a dreamlike landscape where water and air blur together. Standing on shore watching sea smoke drift across the water is like witnessing the boundary between elements dissolve. Watching the ocean transform into air, solid becoming vapor, water becoming mist. Let these images of the ocean's surface settle over you now. The gentle tides rising and falling with the moon. The salt marshes are flooding and draining. The rivers blend slowly with the sea. The foam lines organize across the surface. The windrows strip the water softly. The bioluminescence sparkles in the dark water. The sea smoke rising in the cold. All of it gentle, fleeting, beautiful. The ocean's surface is where we meet it most often, where we touch it, where we witness its moods. And it's full of quiet wonders, gentle transformations, and soft beauty. These phenomena come and go with the tides, with the wind, with the temperature, always changing, always offering something new to see. Rest now in these peaceful images. Let yourself float on the surface of sleep, gentle and calm. Like sea smoke rising from warm water, let your thoughts drift upward and dissolve. Like the bioluminescence, let your awareness flash briefly, then fade into darkness. Let the tides of sleep pull you gently under. Sleep deeply. Sleep well. As we near the end of our journey through the ocean, let's explore a few final wonders, and then rest in the timeless nature of the sea. Breathe slowly. Let yourself drift deeper. Simply listen and allow peace to wash over you. In the coldest polar waters, on the surface of newly formed sea ice, something extraordinary can happen. Frost flowers bloom briefly on sea ice. When the air is extremely cold and calm, and new ice has just formed on the ocean surface, moisture wicks up through tiny imperfections in the ice and freezes instantly, creating delicate crystalline structures that look remarkably like flowers. They're fragile, intricate, lasting only until wind disturbs them or temperature changes melt them. They bloom for hours or perhaps a day, then they're gone. Few people have witnessed them. They occur only in remote polar regions under specific conditions. But those who have seen them describe them as some of nature's most delicate art. Ice flowers growing on the frozen sea, brief and impossibly beautiful. They're a reminder that even in the harshest environments, beauty emerges, fleeting and precious. In these same polar waters, you might encounter something massive and ancient. Striped icebergs carry frozen layers of color. Most icebergs are white or pale blue, but occasionally you'll see one with distinct bands of color blue, green, even brown or black stripes running through the ice. These stripes tell a story. Each layer represents a different time, a different season when the ice formed. Blue layers are compressed ice with few air bubbles. Green layers might contain algae that was frozen into the ice. Brown or black stripes are sediment, picked up when the glacier scraped along the ground before calving into the sea. These striped icebergs are floating archives, carrying within them the history of the glacier they came from, displaying it in beautiful bands of color. They're works of art created by time and pressure, by the slow accumulation of snow and ice over centuries. And once these icebergs break free from the glacier and enter the ocean, they begin a slow journey toward warmer waters. Icebergs melt slowly as they drift. They're carried by currents, pushed by winds, traveling sometimes thousands of miles from their polar origins. As they drift into warmer waters, they gradually melt, bit by bit, releasing their ancient frozen water back into the ocean. Some icebergs can last for years, slowly shrinking, constantly changing shape as pieces break off and surfaces melt. They leave behind trails of cold, fresh water, creating local changes in ocean temperature and salinity. Eventually, they disappear completely, melted back into the sea, completing a cycle that began perhaps thousands of years ago when snow first fell on a distant ice sheet. As they melt and break apart, icebergs make sounds, and in the ocean, distant iceberg sounds travel through the ocean. Remember how sound travels faster and farther in water than in air. The groans and cracks of icebergs, the splash of pieces breaking off, the rumble of an iceberg rolling over, all of these sounds travel for miles through the water. Underwater microphones placed in polar seas pick up an entire soundscape of ice creaking, groaning, cracking, splashing. It's an eerie symphony, the sound of ice dying, of frozen water returning to liquid. These sounds are part of the ocean's acoustic environment, traveling through the depths, heard by whales and seals, by anyone or anything listening in the cold polar waters. Speaking of whales, these magnificent creatures are some of the ocean's greatest travelers. Many whales follow the same routes every year. They migrate between feeding grounds in cold, nutrient-rich waters and breeding grounds in warm tropical seas. Gray whales travel from the Arctic to Baja California and back, a round trip of up to 12,000 miles. Humpback whales make similar journeys in both hemispheres. They return to the same feeding areas, the same breeding lagoons, year after year. How they navigate across thousands of miles of seemingly featureless ocean remains somewhat mysterious. But they do, with remarkable precision, following invisible highways through the blue. And these journeys aren't just individual knowledge. Migration paths repeat across generations. A young whale, making the journey for the first time, follows its mother, learning the route. When that young whale grows up and has offspring of its own, it leads them along the same path. Generation after generation, for thousands of years, whales have been following these routes. The paths are cultural knowledge, passed down not through genes, but through learning and memory. Grandmother whales teach mothers who teach daughters. The migration routes are living traditions, ancient highways maintained not by signs or maps, but by memory and repetition. The ocean remembers the animals that travel through it, and in this way and so many others, the ocean connects all parts of the world. Water that evaporates from the tropical Pacific falls as rain in the Amazon. Currents carry nutrients from the poles to the equator. Whales born in the Caribbean feed in the Arctic. Marine snow that falls in one ocean basin might have originated as plankton from another. The ocean is one continuous body, and everything within it is connected. There are no true borders in the sea, no walls, no barriers. It all flows together, mixes together, lives together. The ocean is the ultimate connector, linking distant places, distant ecosystems, distant lives. We divide it into named oceans for our convenience, but the water doesn't recognize these divisions. It's all one ocean, surrounding the world, touching every shore, and it moves endlessly, without urgency. The currents flow day and night, year after year, century after century. The waves rise and fall. The tides ebb and flood. Water evaporates and condenses and falls and flows back to the sea. It's all in constant motion, but there's no hurry to it. The ocean doesn't rush. It doesn't stress. It simply moves at its own pace, the pace that suits it, the pace it has always moved. There's profound wisdom in this. The ocean accomplishes enormous work. It shapes continents, supports countless ecosystems, regulates the global climate, but it does so without haste. It moves steadily, reliably, and patiently. There's no urgency, yet everything gets done. Everything flows as it should. Its rhythms have continued for millions of years. Long before humans existed, the ocean was here, following the same patterns. Tides rose and fell. Currents flowed. Waves broke on shores. Rain fell and rivers carried water back to the sea. Marine life evolved, adapted, thrived, all within these ancient rhythms. And long after we're gone, the ocean will still be here, still moving, still following its patterns. It's humbling to think about. We are brief visitors on a planet dominated by an ocean that has always been and will always be. Our individual lives are tiny moments in the ocean's vast story, but we're part of that story, connected to those ancient rhythms, sustained by that ancient water. We came from the ocean. In a sense, life began there, and We remain dependent on it, and through all its complexity, through all its motion and change, the ocean remains calm, vast, and constant. Yes, there are storms. Yes, there are changes. But the fundamental nature of the ocean, its presence, its rhythms, its essential character, remains steady. The ocean is reliable. It's still there every morning. The tides still turn. The currents still flow. In a world of change and uncertainty, the ocean endures. It's vast beyond our full comprehension, deep beyond our complete exploration, powerful beyond our ability to control. And yet it's calm. Even in its power, there's a tranquility to it. Even in its vastness, there's peace. The ocean simply is. It exists, it continues, it endures. And now, as we come to the end of our journey together, you can rest in that knowledge. The ocean continues its ancient work. The tides will rise and fall tonight as they always have. The currents will flow. The whales will migrate. The plankton will drift. The waves will form and break. All of it will continue, whether you're watching or not, whether you're awake or asleep. You can let go now. You can rest. You're held by this planet, surrounded by this ocean, part of these ancient rhythms. Let yourself sink into sleep as gently as marine snow sinking through calm water. Let your breathing slow to the rhythm of the tides. Let your thoughts drift away like foam on the current dot. The ocean holds you. The ocean surrounds you. The ocean continues. Rest now. Sleep deeply. Sleep peacefully. Sleep well.